Welcome to Brain Vision.
So in this question, we have this graph of a standing wave traveling to the right, and we know the peak-to-peak length is 6 millimeter, and it travels by distance d, and then we're given a couple numbers. We say like this peak A, it travels 6 centimeter in 4.0 millisecond. So the first thing is that I have to tell you this question has a tiny mistake, or it's not like necessarily a mistake, but the graph is not accurate because from the graph in the book, the amount of the tick mark actually is around 5 centimeter. So like when A moves from here to here, it travels a little bit more than one tick mark. But then the question itself says that the tick mark is 10 centimeter, which doesn't correspond to the graph at all. So this is a mistake that happens for this new edition. So just be aware of that if you are confused about the graph. But here I will be working on this question by sort of ignoring this graph and only use I'll use this graph, but like I won't look at how it's drawn. I will only look at the tick marks, because the only useful information we're supposed to get from the tick mark is that if each tick mark is 10 centimeter, the wavelength of this wave is 40 centimeter. That is one important piece of information we're supposed to get. So I will just use that. Okay, so let's first look at this wave. It has a peak-to-peak height of 6 millimeter, and we're supposed to find, when it's put in this form, plus or minus, what are the parameters in this equation of the wave. So the peak-to-peak length is, because peak-to-peak is 6 millimeter, the amplitude is half of that, it's 3 millimeter. And then in order to find k, we need to find k, the wave number is equal to 2 pi over lambda. And we find that lambda is 40 centimeter. So we can say this. And this gives us k equals 16 radian per meter. And then let's look at part C. Part C says omega. What is omega? So there are a couple equations for figuring out what omega is. I find the easiest one to use k times v. K we already have. We do not know the speed it travels, but we know it travels 6 centimeter in 40 milliseconds. So that is a piece of information that can tell us what's the speed it travels, because 6 millimeter in 4 milliseconds, and together it gives me 240 radius per second. So the last one, it just says minus. I already wrote it here. The reason is because the question immediately tells us that this wave is traveling to the right, and we are like in the positive axis. And we know for any wave traveling in the positive axis, it will have a form of kx minus omega t. And then for waves traveling in the negative axis, we'll have kx plus omega t.